Alright guys, I'm actually going to get us a little caught up in the front too of our table of contents. So on 17 and 18 we talked about function notation. And then we're going to talk about absolute value graphing on 19 and 20. So we talked about solving them up here, but now we're talking about graphing them. So here's our 18 and 19, or 17 and 18 rather, and then 19 and 20. And if you have these flipped, it's really not a big deal. And I want to start over here, okay? So what we talked about in class are, if I replaced our A, H, and K right here with numbers, then I should be able to kind of notice a pattern about how my graph is changing, which then allows me to quickly graph it. So we said that K was moving up and down, H is moving left to right, but it was always moving oppositely, and then A was like our slope. However, I know the shape of my graph is always this V shape. And so identifying this point right here is super important, and we call that point our vertex. And that vertex can be determined by how far left and how far up or down, left or right, up or down I had to go. So if I can identify the vertex, which in this case is my H, K, then I can plot it, and then we need to remember that the stuff inside the absolute value is going to move me again, like I said, left or right. And it was kind of unique in that it was always opposite of what you expected. And then the number being added or subtracted outside the absolute value moves us up or down. And it did exactly what we thought. Okay. So next, we want to identify our A value and use it as slope, which hopefully makes sense because it is the number being multiplied out front in both directions so that we get that V. So for example here, if I gave us like y equals half absolute value x minus 2 plus 1, we want to identify our H, K, so in this case, it would be 2, 1. And if, a number is missing, like it's not being added or subtracted here or here, then we just call it 0. And so I'd plot 2, 1, again, keeping in mind that thing is opposite. Then I'd find my slope, which is half, and we'd do that as like a rise over run thing in both directions. So I'd go up 1 over 2. And then up 1 this way over 2, so I can get both sides of that V. Now we should be able to go in the other direction as well, like if I have a graph, hopefully we can write the equation as well. So I can look at my graph and find my vertex, and like where is that point located. And in this case we're located, and sorry my X and my X's are so crappy here, over 2 to the right, and then down 1, 2, 3, 4, so -4. And then I can count out my slope starting from the vertex and looking for another really nice point that like goes through the crosshairs of my graph. So like right here is good. So then I can count up 1, 2, 3 over 1. And so my A value is 3 over 1, or 3. And so then I can write my equation y equals A for slope, so 3, absolute value x minus 2, because when I put it in, it's going to change the sign, and that's what's making it look opposite, and then minus 4. And hopefully your slope makes sense, because a 3 should be going really fast, and this graph is going really fast. So on the other page here, I'm going to try one of each, and I would hope that you would then try the next ones to make sure you feel good about it. So I would find my vertex to graph, which will be at 1, 0. Inside is opposite, outside there's nothing. So 1, 0. Then I would do my slope, which is 2, and I can always put that over 1. So I'd go up 2 over 1, up 2 over 1, and we could continue to get lots of points if we wanted to get that graph that's going forever. And we'd have that the domain is all, because we're going left, we're going right. We'd have that the range is greater than 0. On the next page, we're going kind of backwards. So we have our equation. I can see that my vertex is at 0, 4. And if I look for my slope here, if I start at my vertex and I find another nice point, we're right here, and I think we went down 1 over 1, so negative 1. Then we'd have y equals negative absolute value x minus 0 plus 4. And then lastly, if I look at just an equation, we want to be able to describe the transformation that would happen. And I feel like if I look at this one, I can tell from the inside that we would move left 3 because of the opposite nature of that. I wouldn't move up or down at all. My slope here is going kind of slow because we're half, so I feel like I would be wider, and then I would be flipped because of the negative over the x-axis. So I think it would benefit you to try each of the bottom ones, and then we'll talk about the rest of it tomorrow.